Today I am here with Kevin, more commonly known as the Backyard Scientist, and as fate would have it, we are actually in
the backyard.
So I recently made a video where I converted a leaf blower into a snowball machine gun, and the first thing he said was,
"You should set those on fire."
So as soon as I got here today, But flaming snowballs aren't actually why I'm here today. Show them why I'm here today, Kevin. So I actually don't drink, but I've heard of people doing this with beer bottles. So either Kevin has some superpowers, or there's some crazy physics going on there that we're gonna try and figure out today.
So neither of us really knows what causes these bottles to break, and there's a lot of conflicting evidence out there, but we have some of our own ideas.
So as firm believers in the scientific method, we are going to science our way to the right answer through a bunch of experiments.
I'll drink to that.
Not yet, you won't, Kevin.
I've heard that one of the reasons people think it's breaking is because when they slam their hand down on it, they're forcing a bunch of air in the bottle, and that causes the bottom to shoot out.
So in this experiment, we're testing the pressure wave theory, where when a person hits it with their hand, they force a bunch of air in, that then creates a pressure wave that pushes out the bottom of the bottle. So we put a cap on the top, so there's no way to force the air in. We're using a rubber mallet just to be more consistent for all of the hits. The bottle broke even though the cap was on and there was no way to force air in, so we are rejecting this theory.
We think carbonation might have something to do with it.
Okay, so to isolate that, we have one beer that's carbonated, one with water, and then we fill this one with sparkling water. So if these two don't break and this one breaks, I think we've isolated that it works better without carbonation.
Yes.
So this bottle is filled with sparkling water, so the theory is that it shouldn't break. And now for the beer. The bottle didn't break, but that was interesting how much it fizzed up. So as it turns out, here's why that happens. When you hit the bottle, it moves down really fast, but the liquid hasn't started moving yet. That creates an empty gap down here that's basically a vacuum or really low pressure. And if the drink is carbonated, the CO2 from the liquid gets sucked into that vacuum and fills it with CO2 gas bubbles. Now since these bubbles are less dense than the drink, they rise up through the liquid and create a chain reaction of more bubbles as they go. Now finally we test the water, and just like with the carbonated liquids, you see this vacuum form on the bottom. Except this time, the bottle breaks. So theory number 2 is confirmed. Non-carbonated liquids work better. But now we just have to figure out why. What are they doing differently to make the bottle actually break?
So what I think is breaking the bottle is the momentum of the water going back and filling the vacuum is causing the bottom to break out.
And I think the break is happening a little bit earlier. When the vacuum is formed, like the air outside is at 14 psi, and so it's pushing in on the vacuum. So it's before the water rebounds, it's actually cracking because of the difference in pressure.
We'll find out.
Round 3, fight!
So we're gonna add some red dye, and then we're gonna slow the camera down to like 7,000 frames per second to see precisely the moment when it happens. So if I'm right, okay, bottles, it should break right there.
No?
Yes! You punk. Yeah, so you're definitely right. It ruptured when the water was coming back, right?
Cracks right after it hits the bottom.
So, Kevin was right. In fact, it turns out that water cavity collapses 10 times faster than it formed, which creates a force higher than the initial hit on the bottle, which is why it doesn't break right away. So now that you know the science, if you want to impress your friends with this trick, here are a couple important tips. Number 1, hit the bottle and not your hand. You want to make as much energy from your strike go into moving the bottle and not just being reacted by your hand. You can even get the neck of the bottle a little wet and then let it slip a bit when you hit it just to make sure it's moving. Number 2, like we discovered, use water or something non-carbonated. Otherwise the carbonation just fills in that vacuum and cushions the rebound force. Number 3, a liquid with a high vapor pressure is good. If you use a liquid with a high vapor pressure, that means the vacuum you need at the bottom of the bottle will form much easier. So hot water is a lot better than cold water because the vapor pressure is higher. Nail polish remover also works well for the same reason. Number 4, be safe. This is glass, and glass can cut you if you're not careful where it lands. Number 5, don't chicken out. It hurts way more if you don't follow through. Plus, you look like this.
Oh, I heard it. Did it hurt?
So I want to say thanks to Audible. I enjoyed recently listening to a book called Ready Player One. It's set in a dystopian future where people's main escape from the bleak world is to log into a virtual reality world called the Oasis. It was created by the richest man on Earth, but before he died, he hid an Easter egg in the Oasis, and he promised his entire fortune to the person who could find it. But he warned, to be successful, you would need to know a lot about 80s pop culture and video games. The story is really creative and intense, and in fact, Steven Spielberg is currently directing the film adaptation. So if you want to listen to Ready Player One, or any book, for free, all you have to do is use the link in the description or go to audible.com/markrober. Thanks for watching.